Here are your examples for 7-4. 7-4 is properties of similar polygons. So we're going to talk about similar polygons and the corresponding sides of those polygons. So let's look at the first concept here. In words, we have two polygons that are similar. Therefore, their corresponding angles are congruent. Notice that here and throughout. And we also have measures of the corresponding sides are proportional. Make sure you understand the difference here. The sides are proportional, the angles are congruent, or the same measure. Okay, so let's take a look at what that means. Here we have a statement that triangle ABC, and notice the different symbol here. This is the sign for similarity. Remember, you had the sign for congruence looked like this. I would definitely put this on your gold sheet. Congruence, this is the symbol. Similarity, this is the symbol here. So we have in symbols, angle A is congruent to angle X, so we have congruence here. B is congruent to Y. Notice we can tell that by the arc marks. And then lastly, we have that C is congruent to Z with 3 arcs. And then we also have line segments, AB, and it's the relationship. Remember, they're proportional. So the relationship of, let's go like this, the relationship of AB and XY, that proportional relationship. But notice that we're not saying that those line segments are equal. We're saying this proportion is equal to the next proportion. So BC and YZ. So we have BC is proportional to YZ. And then lastly, we have AC is proportional to XZ. AC to XZ. So if you compare those side lengths, as long as you keep in this case, it's the larger triangle over the smaller triangle. As long as you keep them all the same, you will have proportions that equal each other. So now let's finish this up. We have polygons. We have polygons that have the same shape are called similar polygons. You know that. In the key concept box, we have triangle ABC similar to triangle XYZ. This is written like this here with the similarity symbol. The parts of similar figures that match are called corresponding parts. And these were all those corresponding parts we were talking about. So let's take a look at problem number 1. Determine whether rectangle HJKL is similar to rectangle MNPQ and explain. First, we need to check to see if the corresponding angles are congruent. So we can check here and realize that all the angles are the same. They're all right angles, so that's easy. Since the two polygons are rectangles, like we just said, they're all right angles. Next, we can check to see if corresponding sides are proportional. So we're looking at HJ versus MN. And why did we choose to do that? Because we have HJ as the first 2 letters and MN as the first 2 letters. So they're telling us that HJ is corresponding to MN. So we have 7/10. And remember, I'm going to keep telling you this, that technically we could look at this as 10/7 as well. It's the same type of proportion. But one thing I want you to make sure that you do is if you start these out as the smaller figure over the larger figure, then you must keep it that way throughout the entire checking of the numbers. Okay, so we have 7/10 for the first one right here. And then we have JK and NP, so that's right here, JK, NP, so that's 3/6. There we go. Then we have KL over PQ, KL over PQ. Here's KL, here's PQ, and that also is 7/10. And then lastly, we have LH over QM, LH and QM, so our numbers there are 3/6. And now we look at this and we say, since 7/10, 7/10 is not equivalent to 1/2, 1/2 would be 5/10, we are not equivalent, and therefore these are not similar triangles. All we need is one exception as we go through these numbers, and we can prove that they are not similar. If they are similar, we would say, of course, that they're similar with a scale factor of, let's say they were all 1/2, we'd say that there was a scale factor of 1/2. Please press pause and do letter A. Okay, let's discuss our important point here, finding missing measures. Scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. You can use the scale factor of similar figures to find missing measures. Okay, let's take a look at what that is going to look like. Problem number 2. Quadrilateral WXYZ is similar to quadrilateral ABCD. So here's our two quadrilaterals. Describe the transformations that map WXYZ, in other words, the larger, onto ABCD, the smaller. Since the figures are similar, they are not the same size. Choose two corresponding sides and determine what transformations will map one onto the other. A translation followed by a dilation will map AB will map AB onto WX. Okay? In other words, we could slide this figure over to here and then shrink it or reduce it, do a reduction, and we would have this figure mapped onto this. So we're just going to stick with just these two line segments for now. So it says find the missing measure. Find the scale factor from quadrilateral ABCD to quadrilateral WXYZ. Well, we do that by taking, let's go YZ to CD, so we have YZ right here to CD, so we have 15 over 10, that's where we get our numbers here, and 15 over 10. We could divide both of these by 5, and we end up with 3 over 2. So a length on polygon WXYZ is 3 over 2, or 1.5 times as long as the corresponding length on polygon ABCD. Let M represent the measure of XY. So now we're looking at XY right here. Okay? So if M equals 3 over 2, that's our scale factor, times 12, 3 over 2 times 12, we could do this, 12 over 2 equals 6, so 3 times 6 now is 18. So that's how they get the 18 here. Okay, so that's one method here. So we're trying to find this missing measure of M. The thing I didn't point out here, folks, is this 12 right here. It's kind of covered up here. I'm going to clear this off in a minute so you can see this better, but look in your book and notice that this is where the 12 came from. Okay, now there's another method we could use here. Let's take a look at it. It's hard to fit this all in one screenshot. So in method 2, we're going to set up a proportion to find the missing measure. So in this case, we did XYBC equals YZCD. So we have this proportion here. We're going to replace some numbers there. We can replace XY with M per the figure. Look in your book. The BC length is 12, and we have 15 over 10 for the YZCD. So now we have M times 10, and if you'll recall, the reason we're doing M times 10 here equals 12 times 15 is this is that cross multiplication that Mrs. Shaw taught you last year. So M times 10, I always just write 10M equals, so right here's where I got the 10M, 12 times 15. Well, you can do 2 times 15 is 30, and 10 times 15 is 150, so add them up and you get 180. So since we have 180, we can divide both sides by 10, and we have M equals 18. So there are two different ways to do these problems. You can look at it this way, find out your scale factor, use your scale factor times the given measurement that you have. Remember to be careful about how you do this. If you're going from a smaller figure to a larger figure, make sure that you're using the scale factor of 3 over 2. In other words, it should enlarge, not the scale factor of 2 over 3. That's the best way to double check to make sure you're multiplying by the proper number. Just ask yourself when you're done, did you get a bigger or smaller number, and was that what you were looking for? And then the other way, of course, to do it is to set up a proportion and then use cross multiplying in order to solve your proportion. Please press pause and do letters B and C.